this YouTube channel. My name is Jason Tel from University Department of Networks, doing software engineering. This feature explains the contents of the AI term paper that we created with regards to handwritten-notes recognition system. Now, in the abstract section, AI has become an integral part of our day-to-day lives, being applied to solve various challenges. Of course, in this case, we are applying a convolutional neural network to solve the problem of the conversion of the vast amounts of time wasted in conversion of handwritten text into soft copy through typing the keyboard. So we are going to be using an AI system that's going to be able to do it automatically without you spending all that amount of time. We can use that time to do some other things. At the same time, this very document will include the various OCR technologies that are currently in use and there are various challenges and how we are in our project going to improve them. At the same time, also we discuss a comparison of the different, actually the 5 AI models, supervised learning classification models that we have trained, and all of them have been given access to the same data set, and then the different accuracies they give, and then based on this, we choose the best model, that is the convolutional neural network, which we use to implement this project. Same time, we also discuss accountability, how it's going to be ensured. As you know, accountability is a very vital topic when it comes with regards to AI, who is responsible for the actions of this. And I also talk about the keywords. Here we have artificial intelligence, optical character recognition, and handwritten-notes recognition, plus text image. So these are our keywords. Introduction. Now, artificial intelligence refers to the ability of machines to do tasks which, when done by humans, require application of intelligence. Now, as you know, OCR is an AI technology that enables machines to recognize, interpret, and manipulate optical characters. Now, AI system is also a specialized version or form of OCR. And writers, scholars, and all people engaged in the system of creating documents, either news reporters and all kinds of the like, they have a challenge of spending vast amount of time converting their, let's say, rough or handwritten notes into soft copy that can be later edited, let's say for production or any other reasons. Now, handwritten-notes recognition refers to the computer's ability to detect and interpret characters. It can be from various sources. This can be touchscreens, paper documents, drawings, and others. Now, AI system is able to scan the handwritten notes, convert them into digital format, which later can be edited, and work in every other way that you can ever think of. Now, moving on to the background and motivation. Now, artificial intelligence is a term that was coined to refer to the ability of machines to do activities that require intelligence, as already talked about, without being explicitly programmed. Now, today, AI is a diverse field of study. In fact, some people specialize in it. It's very broad. Some of the areas could be natural language processing, robotics, deep learning, and also not forgetting the optical character recognition. Our project is that specialized version of field of artificial intelligence, which deals with optical character recognition. So it can be implemented in various ways, that is OCR, but at the end, the major aim is always to convert the optical characters from the different sources into digital format that can later be altered. Now, for literature review, at this point, in this section of literature review, we talk about the various models that are already in the market implementing OCR technologies. Some of them, the few listed is actually the support vector machines and also the hidden Markov models. Now, at this point, I'll cite out the challenges with regards to the support vector machines and hidden Markov models. Now, for support vector machines, it is difficult to select a good kernel function. And secondly, it is difficult to understand and interpret and hard to visualize the impact of SVM models. So this is a weakness in it. For hidden Markov models, there are many unstructured parameters, and algorithms are expensive in terms of computational time and memory. At the same time, their training requires repeated iteration. This can be time consuming. Now, our contribution, this is how we improving on the other issues already mentioned before. Now, for our model, after a good study, we come to the conclusion that the best way to implement this is through a convolutional neural network. Of course, this comes as a result of comparison of the 5 models which I initially talked about. And then we come to the conclusion that the convolutional neural network is the best. Now, at this point, I'll talk of the different layers of the convolutional neural network. Basically, there are 4. First, the input layer, then the convolutional layer, the polling layer, and the fully connected layer. Feel free to pause this video and have a good look through these notes. It's really much. I'll move on to the methodology. Now, methodology, we're talking about the various steps involved in implementing all this project. Now, first of all, we do data acquisition, wrinkle 4, pre-processing, then data segmentation, classification, and post-processing. Now, each of these steps does not happen like happens and then the whole thing works out. But the process goes step by step. In data acquisition, we have to get the data from various sources, and then we feed into the algorithm. In pre-processing, those are the steps involved in organizing the data, either cleaning it, exploratory analysis, and the like. In segmentation, that is splitting of, let's say, you're having a full sentence, we are trying to recognize non-recognition, you're trying to chop into letter by letter, or if they're multiple lines, line by line, then letter by letter, and then being able to do the recognition. Then next, after you've done that, you do what we call classification and recognition. Of course, after you've identified individual characters, optical characters through the process of segmentation, the next thing is to be able to classify them into the corresponding ASCII characters. And there's a step of post-processing. Now, move on to our dataset description. Now, our dataset was obtained from Cargo. And I'll talk about at this point the various factors we considered before choosing this dataset. First of all, we needed, one of them is accuracy. Now, we needed an AI model that will be able to give very accurate results. Now, accurate results, just like in the computer language, garbage in, garbage out. If you expect your model to be very good, then it must be trained on good data. So this is where the concept of accuracy comes in. Now, the AI system needs to be trained on accurate data, as this serves as a base point for the learning process. And accurate data serves as a point of truth upon which patterns are learned in order to make future predictions. And secondly, it's relevance. Now, the dataset should be relevant in explaining the labels associated with the observation. The other is quantity. Now, since our machine learning model required a vast amount of character images, large amount of this data was considered, and this was obtained from Cargo. Variability is the last factor. Now, the dataset should include data images from different levels, sources, and capture different use cases to allow our model to have a broader understanding of how the dataset affects the output. And secondly, I'll consider the different features in our dataset. Now, upon which the model was able to learn and be able to do correct classification. One of them is the image curvatures. And the system was trained to detect curvatures of different character images. And these work in conjunction with other features for classification of characters. And the other is corners, and the edges, then the ridges, and the image size. Now, feel free to pause the video and have a good look through these simple slides. Now, the next concept is data preparation and exploratory data analysis. Now, like as I already said, our dataset was downloaded from Cargo and was found to contain 3 folders: the train folder, validation folder, and test folder. Now, each of the folders contained other folders for each of the categories of images. Now, of course, the images and categories of letters of the English alphabetical system, plus also numbers 1 through 9, some special characters. Now, since our dataset comprised of images, as you know, it was impossible to come up with some data visualization figures like the box plot, heat map, outlier plots, and also a correlation matrix. So, for this reason, for the same reason, there were no missing value as the letters of the English alphabet and decimal numbers were all captured in the dataset. Now, a total of 18,104 images from the train folder were used to train the model, and 15,209 images from the validation folder were used for model validation. And the sample of the images that were used after training and validation. Now, figure 3, which is on the right, as you can see, it's a snapped image of a sample images that we used to train and validate the model. Now, next I'll talk about model selection and optimization. Now, to measure performance in order to select the best AI model for our project, we created and trained, validated, and tested 5 AI models. Based on these results, we are able to select the best model that could be used to implement our solutions. Of course, now, like I said, we're based on accuracies. Now, these 5 models that we actually tackled, one was the naive classifier, then the k-nearest neighbor, then the random forest classifier, and the support vector machine. Now, details about this are also listed here. Please feel free again to pause the video and look through. Now, I'll take you straight away to that table that shows the various results that we've obtained from the different models and algorithms. Now, one of them is naive Bayes, as you can see. Just look at the column for accuracy. You can see naive Bayes, random forest classifier, k-nearest neighbor, support vector machine, and the CNN, that's convolutional neural network. You can see highest accuracy was achieved from convolutional neural network, and for this reason, SWOT was selected to implement our model. Now, talk about accountability. Now, accountability refers to the need to justify one's activities and actions. The AI system we are developing. Of course, now for this project, we've ensured accountability in the various stages of the AI lifecycle. Of course, now I'll cite the various stages. One of them is the design. Now, here we articulated the objectives of the system, then the goals and underlying assumptions. This also included the general performance requirements. Now, the process of development, AI accountability was ensured at this stage by the action of redefining the technical requirements. We collected and processed the data and built the OCR model, and finally, the system was validated based on the above actions. Next is deployment. This stage had accountability ensured by the actions of piloting the project, validating its compatible status with other competing systems, sites, on competing devices and systems. And in addition, we ensured that the system complies with regulatory standards such as OCRV. Then, the last stage is monitoring. Now, monitoring at this stage, from time to time, we've been monitoring and assessing our system's output and the effects on the users. Now, based on this, system may be modified accordingly. So this is how we ensured accountability. Now, results and discussion. Now, the model was trained on 96,000 character sets using the Adam optimizer, giving accuracies of 97.9 and 99.3 accuracy. Now, the model here I'm talking about is the convolutional network after we selected it as the best performer. So for it gives 97.9 and 99.3 accuracy levels on train and validation set respectively. So we split the data in the ratio of 70 to 30. 70 is training set and 30 for the validation set. So we carried out a training using 70 epochs and noted the accuracy after each epoch. And the accuracy seems to increase drastically in the initial epochs and gets saturated in the higher iterations. On the other hand, model loss was always declining, as shown in the figures 1 and 2. Now, figures 1 and 2 are depicted actually on the next page. Now, the nature of our images in the dataset could not enable us to generate a confusion matrix, as each of the images contain multiple characters. Now, sample these images you can see on the right. That's sample figure 5, which shows the Valentine, and then down you can see which obtained by sniping. Figure 6, the Valentine, as you can see it being segmented. Now, at this page, you can see the two diagrams, figure 1 and figure 2. Figure 1, which is training loss versus validation loss. So you can see, as already explained, the losses were always declining. At the same time, for the training accuracy versus validation accuracy, these ones were increasing initial stages or the epochs, and then later they come to almost a constant value. That's the saturation value, as you can see there, the 90s. Now, for conclusion and feature works in this chapter, the character recognition system using a convolutional neural network has been achieved based on image preprocessing character segmentation, feature extraction, and classification process. Because numbers and characters of the English alphabet have been recognized and classified, and the proposed character recognition system performance was evaluated, and a high rate of recognition was achieved. Now, for our future, we hope that the CNN algorithm, that's the convolutional neural network, which has been used for segmentation and recognition of the English characters. Now, in the future, this can be extended further for recognition of numbers, characters, and other special characters from various languages and scripts with a few edits. Now, the proposed algorithm for segmentation also can be modified further to improve the accuracy of segmentation, and new features also can be added to improve the accuracy of the algorithm, and use algorithms, and these algorithms are allowed to try on large databases of handwritten and digital English characters. Moving on, here we have some of the links, our Python source code. Now, this is being held in a repository on GitHub. Feel free to pause the video and look at them in the YouTube description, just on there, you can be able to follow along. And then there is also a link to our dataset, which is got from Cargo. Now, acknowledgement, special thanks to Mr. Marvin Galiwango and Dr. Nancy Rose. These are lecturers at Macquarie University. These have prompted and guided us throughout the course of this one to ensure the success of this AI term paper. This last page is a depiction of our references, like where did you get our information, the research you made, and special thanks to all these individuals who gave in their time to make these research documents. Thanks.